Hello. Hello. Welcome. Welcome, everyone. I'm sorry that took so long. Um, yeah, that was something I was meaning to do ever since I reset the points. Um, I reset the points just so I could keep track of, if people were actually watching recently. Um, and now already we can kind of see that there's a slightly different clientele of people who are watching, or at least I can see. Um, yeah, it's not a huge difference, but it's useful for me. So that's basically why I did it. Um, and yeah, so anyhow, you're wondering why we're here. I need to close my door. The door has been successfully closed. Okay, now we can begin in earnest. I think I need a different song. Mm, sure, let's go with that. Welcome everyone to the official kickoff of season 2, rather than the unofficial kickoff of season 2, which was yesterday, or 2 weeks ago, 3 weeks ago, whatever, whenever the time was. Anyhow, now it's officially season 2. Season 2, baby! Welcome! Welcome to season 2 of making stuff uselessly. Alright, so, yeah. What happened since season 1? Well, a lot of things happened. I suppose first thing that happened, all the way over here, this bad boy. Beautiful. That's my iron ring. I'm actually supposed to wear it. It's my iron ring, so now yup, I finished school except for one course which I'm taking over the summer. But more importantly, we had a whole charity drive that happened like in the middle of Christmas time, and I forgot to save any of the live streams. So it's just lost to time, unfortunately. But it did happen. We raised how much money did we raise? It was a lot of money, a surprising amount of money. In fact, let's just pull it up. It was how much money was it again? It was people were way too generous. That's what it was. People were way too generous. Basically, rundown. My sister got diabetes. That was sad. She's okay, but it kind of sucked. Oh yeah, here we go. So if I just switch this to right monitor. Here we go. There it is. So yeah, we had a whole campaign, yada yada yada. How many did we get? Oh yeah, so once all the matching was considered, $1,060, which was way more than I was expecting to get. We had several people donate $100 some. It was pretty incredible. Anyhow, because of that, a bunch of stuff happened. Let's turn off. No, not that one. Let's turn off that one. There we go. Because of that, we did some various other things. I know that I added in an extra character who has not appeared yet, but he will. Mr. Time Spiraled, one of my now followers, which is super cool. The other thing that happened is I got really demotivated because none of my puzzles were working, as you can see. Look at this. I don't even know. I just kind of gave up for a bit. But then I came back, and I started just trying some things out. I made this whole map off of any live stream, so nobody got to see this. It still looks super jank, and I'm not happy with how it's laid out right now. But hopefully we can fix that, and that's something for a later date, because right now I want the mechanics to work. The other thing that happened while I was still off stream is that I did this mess. Oh, okay, I suppose that's not all that I did off stream. So the first thing I did is I sort of planned out this puzzle. It just sort of came to me one night. It's a bridge puzzle. Okay, so here's the basic gist. Actually, you know what? I have a second camera for this. Wait, what's going on here? Is this broken? There we go. Now it's fixed. I have a second camera. That's what the second camera is for. Let's move some of this stuff out of the way so I can show you properly. Okay. Now I can show you properly. Desk camera. Here we go. There we are. Look at that. Look at that. Okay. So. Okay, so. We have. Here we go. So we have a bridge, you see? And there's 3 different spans of the bridge. We've got one that's 12 wide, or we can call it 1 unit. Then we have one that's 3 units, and one that is 2 units. Simple enough, right? Simple enough. And you can see that... Oh, wait. I would have to... I've forgotten my shortcuts. Oh, wait. Okay, my shortcuts just don't work. Okay, well, ignore that for now. Anyhow, that's what the map... Okay, thank you, Intense Music. That's what the map reflects as well. Just trust me on that for a second. I'll show it to you once we're done here. Okay, so then we've got our units, whatever, yada yada yada. So this gives us a total length of 6 units. 6 units, beautiful. So then we have on easy mode, you're going to get 4 different types of pieces to construct the bridge. You're going to get one that is 1 full unit, one that's 3/4 of a unit, one that's a half of a unit, and one that's 1/4 of a unit. Well, I suppose not one of each of those, but you know, you'll get some of each of those different piece sizes. And for medium, we have different sizes, like, is that 5 of 6? I don't think I ended up ever actually making 5 of 6. So I don't think there is a 5 of 6. But 2/3, 1/2, 1/3, 1/6. I'll have to check again what we actually decided on some of this, because these numbers are different from some of the numbers that I actually started to go with. So anyhow, you got all these different pieces as small as 1/12. Nice and fun. And then I did some math to try to give sort of a randomly generated bound. So we're going to randomly generate these pieces for the player, and then it's going to fit within some bound. And these are, I think, the minimum possible it would take and the maximum that you could do it in, or the maximum possible pieces that it would take if you were given the largest pieces and the smallest pieces, basically. But yeah, hopefully our algorithm is going to make it a little bit easier than that. So, because guess what? I didn't just stop at 1 piece of paper. Oh, no. That's the 3rd piece of paper. Okay, because here's our next piece of paper where I started designing an algorithm to give the pieces. I want to move this over so it's a little closer to the other camera so I'm not looking so far. Okay, so I can't even read my own writing. Selection algorithm. Okay, so first we have a total cost, then we get the difficulty, then we select the number of pieces to give the player. Oh yeah, that's it. Select the number of pieces to give the player. And that's supposed to fit between values like this. I ended up changing these values to different ones, as you'll see later on probably. And then we have all these different probabilities for each pieces. So you can see on easy, we've got like the one piece has a 15% chance of occurring. Very nice. Or the 3/4 piece has a 25% chance of occurring. Very nice. And medium has, of course, different pieces with different probabilities. So like the one has a 10% chance instead of a 15. Pretty nice. You have a 30% chance of getting a 2/3. There's the 1/2, the 1/3, and the 1/6. So no 5/6, as I said. And of course, different probabilities on all of those. Hard and very hard, you never get the 1, because it's just too easy. And, you know, different probabilities, so on and so forth. And over here we have the number of tiles that each one takes, because each one represents one tile. No, sorry. So each 12th represents a tile, because that was the easiest way to do it in RPG Maker for me, as far as I could at least think and conceptualize it. Then we have some other steps for the selection algorithm that we're going to work on today. That's what we're working on today. I'll get to that in a second. Okay. Next page. Next slide. Then this was conceptualizing it in a different way as perhaps like a warehouse, because for a while I wasn't sure how to do it with the bridge and stuff, and I'm still not entirely sure how to do it, but hopefully we'll figure it out at some point. And yeah, for this, I actually started making some mock-up models out of Lego, because Lego was the easiest way of doing it. At first, I'd made it out of paper, and it was just a mess. So then I went and I got out the entire bin of Lego, and I made this. And you can see we have a 1 span with 12 bricks. Here, let me just make that a little clearer. So it's 3 studs by 4 studs. Easy enough, that's 12. And this is twice the size, so that's a 2-unit width, which is 24. And we have a 3-unit, just like our different bridges, except that they're not in order, because they're in consecutive order instead of, yeah, this order, where we have 1, 3, 2. Here we have 1, 2, 3. This just looks a little more aesthetic, I think, whereas this was just easy to keep track of when I was building it. Anyhow, then what I did is I wrote my pseudocode in 2 or 3 different places. Oh yeah, this is a different page for a different puzzle. That you know, the one that was on hold, because yeah, I didn't like the way it was going, basically. Here. Oh, I just realized that... Oh, wait a second. Is my desk camera actually correct? I don't think it is. I think I need to filters. Configure video, perhaps? Camera control. So we have it on vertical flip, but not horizontal flip. So I need to add a horizontal flip. However I do that. Flip horizontal. There we go. Now you can actually read, maybe. Let me actually adjust it, because it's really off now that I look at it. So anyhow, that's why there's a massive mess of Lego brick, because yeah, I made an absolute ton of these pieces, and yeah. As you can see, some of them are a little bit acted. Most of them are too janky. And they're all taking up a lot of space on my desk. Which is why we're streaming tonight, so I can get them off my desk and back in the bin. Yay! Back in the bin you go. Okay. Anyhow, so here we started writing the pseudocode. And the first thing that we did in this pseudocode is we have a little bit of a thing that I'm still not happy with how this is. You know what? Fine. Hopefully it's not too bad. Hopefully that's somewhat legible for you. Oh. Let's get Maya Solove up there. Anyhow. So so the first thing we do is we have this difficulty if-else situation going on, and then we assign a set number of pieces to it. And as you can see that the low end and the high end are very different for this than we had before. Like, where is it? So, like, here's our maximum case at 6 and 24 for easy, and we have 8 and 20. So, pretty close. But I'd originally planned 8 and 20 still. But then if we go to, like, very hard, the minimum is still 6, and the maximum is 72. The maximum upper limit, that is 72. And at first I had 22 and 60. I cut that down to 16 and 32. So it is going to be a fair bit more challenging than the actual upper limit case, and it's a fair bit more challenging than this. But it is going to require a fair amount of testing afterwards, so we're definitely going to have to do some of that if we can, actually get this working. Then we have a bunch of garbage that sort of got used, and then we have different puzzles on the next page, because, I'm just that smart, and I decide to splice pages in together where they don't make sense in my notebooks. It's a genius idea. Although this is a genius idea. This is going to be for the boat puzzle again, and hopefully we'll be able to come back to it. I guess this is a little sneak peek at some of the stuff that we might have later. Anyhow, I am actually going to need that page open. Here we go. Okay, I'm going to need that later. Then, I kind of skipped ahead a little bit. Or behind, I'm not really sure. Anyhow, took an entirely different notebook on a different occasion and started writing pseudocode here. And once again, spliced it with something completely different. I don't think this is even related to any of the stuff here. I think this was just me messing around. Yeah, I think this is more related to these two things, which are just fun math things that I was doing, as one does. And then I started trying to write pseudocode for UI stuff and how all of this garbage on the screen is going to work, because still haven't figured that out. Then I started designing an allocation algorithm to the different pieces to give you a random set number of pieces, which is fun. And yeah, that's basically what we're going to do today, so I'll go through that in a second. More importantly, though, let's go over what we actually ended up doing, because pseudocode is all fun and good, but it's also garbage, so, it doesn't do anything. So let's go over what we actually did. And turn off the desk camera, because for some reason my shortcuts aren't working. Okay, so the first thing we did is we set up the total budget to be 72 because we're going to need 72 tiles because 12, 112 times 6 because we have 6 units of 12, 72. Simple enough. Very simple basic stuff. Then we define what the bridge pieces are, and this is something I did like 2 days ago, and you know, this was kind of a pain at first. So let me explain what's going on here. So first, we have this $ data map infos, which is a thing that exists in RPG Maker that I'm basically piggybacking off of. I'm basically taking a thing that was used for the engine that the developers of the engine intended to be used in one way, and I'm basically hijacking it in order to make this puzzle work. Because it was the easiest way that I could actually make all of this garbage work. That it was basically the easiest way that I could create a new object. Yeah. I had to go onto the forums for this. Originally, I just wanted to be like $ bridge pieces and just go with that. But that just doesn't work. At least not from what the forums are telling me. So I tried. Doesn't work. At least not without writing like a plugin, and although maybe I could learn how to, I don't want to. I wanted to do as little work as possible, which is like the motto of this project. I want to do as little as possible in order to actually make a game that can be released, and then we go from there. Then we define each of the pieces as an object within an array. I know, sounds fun. Okay, so basically, we've got like this whole table of all of these pieces. Like, here's the... Which one is this? Here's the 5/4 piece, right? So its name is 5 out of 4, and it costs 15 units, which is 3 times 4 plus another 3, 15 units. It costs 15 tiles. And what other information? Oh yeah, and it has some distribution. We didn't actually set that up. Oh, I have it set as number. I think I actually want to change this to quantity. Yeah. I know, it just feels right, you know? Number just is kind of vague, whereas quantity is a little more set in what it is. It's a little more restricted in what it can mean. A little less ambiguous, there we go. Sorry, I've gotten distracted with the formatting of this. Don't worry, I'll fix it in a second. Okay, now that that's sorted, we can move on with our lives. Okay, so, okay, right. So, first, we take this data map infos, which already exists in RPG Maker. We steal it, then we tag on bridge pieces as a property to it. So we have this global object, and we yoink it, hijack it, slap on this extra bridge pieces property that the rest of the engine doesn't know what to do with, because this doesn't exist as far as the rest of the engine is concerned. So it's just like, oh, there's this extra bit of data here that's just kind of here. I'm not using it. Okay, cool. Have fun. Except all this time, we were there hijacking it. We're like, now my data is packaged in with your data, and you're not going to use this data. You're never going to access it because you don't care. But I can then, when you're done doing all of your garbage, can take it out and go, oh, look, all this extra data that you didn't know that I had. It's kind of a cheeky solution to the problem. I'd rather define my own global variable like this, $ bridge pieces, something like that. But yeah, as I say, it's a pain to do. It looks like I'd have to figure out how to write plugins, and I don't want to write plugins. It's just a pain. Okay, so then within bridge pieces, because bridge pieces is this property that we've tagged on, but it has no value assigned to it. It's just like an empty box. We can put whatever we want in the box. So what we do is we fit a table in that box. And in that table is every different kind of piece. So we have every single one of these Lego pieces. We've got one for this one for this one for this one. I'm actually really glad that I took the time to make all these, because it's very convenient now. One for this one, all that fun stuff. All that jazz. And then, within each slot that we have for each of these pieces, then what we do is we go, okay, now I'm going to define an object, which is a programming way of saying, now I'm going to create a thing. I'm going to create, like, what's a good way of describing an object without using the word box? Now I'm going to make a thing, and I'm going to define several properties of that thing, and that's what an object is. And so, like, the properties that we've defined here are the name, so, like, 1 out of 12. Where's my stack of 1 out of 12s? Here we are. So, like, here's our 1 out of 12 piece. We've defined this as an object in this table. So we take this and we say, you will call this, we put it in the table in its correct position, and we say this is called 1/12. That's its name, 1/12. That's what we're doing right here. It has a cost of 1 tile. And, it's got 1 stud, so it's got a cost of 1. Okay, nice enough. Then we say, to start out with, your quantity is 0. You get none of them. 0. You don't get any. They're all mine. And distribution, since we're just defining things, we're not going to tell you what... We're just going to say that none of the pieces have any distribution. They all get a 0. So there's a 0% probability of getting any of the pieces until I tell you so. That makes sense? I think that makes sense. Then we have our difficulty setup, which is basically getting the difficulty. So first thing we do is set the difficulty, and that's using a common event. So let's just go to the common event, make sure that makes sense. Set difficulty. So the first thing it does is check if the selected difficulty, like if you've previously selected the difficulty. If you have selected the difficulty before, easy enough. We'll just use that number. We don't need to waste our time here. Just use that number, But if you haven't, then we go through this whole process of setting your difficulty, yada, yada, yada. And then we, of course, end the loop and say that difficulty has been correctly selected. There you go. So that's all that does. Now that we have our difficulty setting, we have to set a bunch of properties for our puzzle according to that difficulty. So like here's easy mode, and we say you get a maximum of 20 pieces, but a minimum of 8. And then we set this distribution in accordance with this table. Look at, this table that we saw earlier. So as you can see, a 0% probability of getting 1/12 on easy mode, 0% probability right there. It's the exact same table. Nice and easy. And as you can see, 40% in the third box, 40% in the third piece type. Third piece type is 1/4, so there's a 40% chance for your 1/4 piece. And then we do the same sort of thing with medium and with hard and with very hard, because it's no good just defining all those properties for a single difficulty, obviously. Then we set up the piece distributions, and to do that I had to use a loop. I don't like how RPG Maker implements loops, but I did it anyhow. So there are, I believe, 13 pieces. Just want to check that. Yeah, so there's 13 different pieces, but of course we're gonna start at piece number 0 rather than piece number 1, because that's how JavaScript does things. So piece 0 is our first piece, which means that this number 13 would actually represent the 14th piece. That's why we want to stop the loop or break the loop when we hit 13 or more. Then what we do, and here's where the fun really gets going, is we set the distribution property that was set to 0 here, and we set the distribution property of, you can see this game variables .value 303, that is this piece iterator. So whatever number we're on currently, you set that index within the table to the value given by, this is the 302 is the distribution, so you set that to whatever value is in here, is in whichever slot within that table as well. So you basically just match up what's in here to what's in our properties up here. And then, yeah, just iterate through all the pieces. And then we have to set the total number of pieces. So this was fun as well. So we set the low number of pieces that we want to have. So for easy mode, that's 8 pieces. We want no less than 8 pieces. And we want a high number of pieces. So no more than 20 for easy mode. And then we use this common event that finds a random integer within this range of 8 to 20, or whatever it happens to be, depending on the difficulty. And then we take that random value and we set it to the actual piece count that we're going to give. Then we just reset what is going to be the result from this, because we just don't want it to get used for other things accidentally. And then we have this extra piece count, which is an extra 10% off of this random number right here. And then we just have a bit to print that for just to understand that. And then I just added this loop for debugging purposes. So I'll just go ahead and show you what that looks like. Now that we're, 40 some minutes in, I've finally explained where we got to previously. Okay, so let's pick easy mode, right? So it should be between 8 and 20. 9 is between 8 and 20, so that checks out. And then 9 times 10% rounded to, well, I guess rounded down to the nearest integer is an extra 0 pieces. So we'll have 9 normal pieces and 0 extra pieces. So this would actually be fairly challenging, I think. A fairly challenging, easy one. You don't have a lot of pieces there, unfortunately. And then, see, we've tried it again. 8, still getting 0. Maybe I should make that round up instead of round down. And as you can see here, we got 15 pieces, which is still between 8 and 20. It's substantially higher, though. And then 1 extra piece. That's very nice. Yeah, I definitely think I should have that round up. Or at least just round instead of rounding up or down. 10, you get 1 extra piece. 13, 1 extra piece. So on and so forth. Simple enough, right? So let's just go ahead to the bottom of this absolute mess. And what we want to do is I want to make this round up instead of round down. Math.ceil, and hopefully that's correct. Let me just check that that is an actual JS function. JavaScript math.ceil. Okay, good. That is correct. So this should work. We'll just give it a test, you know, as one does. I have realized that I left the light down here. Oh, okay, so just grab a new game. Easy mode. Okay, so now it's rounding up. Good. As expected. Cool. So that's all working. Now, we just have to figure out how to write the selection algorithm for which pieces it's actually going to give you. Oh joy! Not as simple as just a random value, unfortunately. So, let's start with our pseudocode. So first we get our number of pieces. Yup, that's all good. Okay, so the first thing we have to do is get this into a more useful distribution. Because while it's useful to know what percent chance a given piece is gonna be a certain type of piece, we actually need the computer to be able to figure things out. And how we're gonna do this is we're basically gonna have the computer generate a random number every time we want to select a piece, from 0 to 100, so 0 to 100%, right? And what we want to do is we want to have each, so we'll generate a random number, and then we'll see which range that fits in. So I have a feeling we're going to have to do multiple iterative thingamagums. And we may actually want to change how our distribution works. So what I could actually do is I could just set this to so I could just add these together like this, and that'll automatically do all of that work for us. So this would be 85. I'm not sure that I actually want to do it that way though. It might be easier to hard code this. It might be easier just to do a ton of if-else statements. So I think I actually want to use a new event. Or at least a new self switch. Yeah, so we'll make this our piece selection algorithm. So let's just yeah, it might actually be easiest if I don't actually define distribution. And I just use I just hard code it. Because I'm trying to think right now of the best way to do it if we don't hard code it. And I'll be honest, I'm kind of drawing blanks. Like, it's definitely possible. It's 100% possible. But I think it would be really hard for me to understand what was going on then. And then it's really hard to fix and debug and that sort of thing. So I think I do maybe just want to hard code it. I think we'll leave the distribution variable alone for now, and all of this as well. But then we will just hard code it. Okay, so the first thing we need to do is create a loop. And the next thing we need to do is create the condition for why that would close. So we'll start by controlling a variable, and I've been using the 300s, so we'll actually use piece iterator. We'll set it to 0 at the very start. And I know that we used piece iterator elsewhere, but since they shouldn't overlap, we should be fine. Then we will set our conditional branch. And this is going to be what exits the loop. So we start out with I equals 0. Oh my word, I wish I could read my own writing sometimes. Or while cost is less than pieces minus sum of... I have no idea. Piece, P-E, piece, oh! Oh, the number of piece types, I see. Wait, what does that have to do with anything? Sometimes, man. Sometimes my brain works in ways I don't understand. Okay, I think let's just go with the... Okay, variable piece iterator is less than or equal to piece count. Oh, actually, we want this to be strictly greater than, and then we will break the loop. And right now, that's going to be the only condition we use. Or maybe we don't need to hard code it, because I do have pseudocode that... But this is going to require, I think, a second loop. So we'll go ahead, add a comment, main selection loop. Yeah, so I think we do actually want to change how this is done to 40, yeah, like that style, which means that this would be 35. So 35 plus 25 is 40 plus 20 is 60. That's going to be 90. And that's going to be 100. Okay, good. My math is acceptable. 15 plus 15 is 30, of course, as we all know. 30 plus 25 is 55. Plus another 5 is 60, plus 10 is 70. Plus 10 is 80. Plus 20 is 100. Good, so our math is still okay. And let's actually change this to a 3, and let's change this to an 8. Oh wait, no, can't make that an 8. Let's make it a 7. There we go. And we'll make that an 8 and that a 12. Okay, so 10 plus 5 is 15. Plus another 5 is 20. Plus 8 is 28. Plus 3 is 31, which makes this 41. Plus 7 makes it 48. Still 48. We can leave the 0, I think. 48 plus 15 is going to be 53 plus 10, 63. Plus 12 makes it 65, 75. 75 plus 5 is 80. Plus another 10 is 90. Plus another 10 is 100. Okay, good. My math is not insane. Oh yeah, and we can just leave the zeros, because if we do it by strictly less than, and it's between 0 and some number, it will always be strictly less than, like, we'll never have a number that is strictly less, because our random number is going to be between 0 and 100, so we will never have any number that is strictly less than 0. Okay, so now we can actually make our loop. Okay, so next, we make a loop, and this loop is for the cycle through pieces to allocate. So we add another loop. Ah, and here's where things get fun. Okay, because first we're going to need a variable. Control variables, right. Piece type. Let's change this to current piece instead of current piece name. So we'll start that on 0. Oh, and we will have to... Oh no, because that just sets it, right? There's no adding going on. Perfect. Okay. So I think we can actually copy this, except we're definitely going to need a different script and a different condition. We'll set this to current piece instead of piece iterator is greater than or equal to 13. Then break the loop. We're done. Otherwise, do the condition. And here we add... let's actually add a comment. Check to see if we've gone to all the possible piece types. If yes, then stop. Then we will add another conditional branch. I think actually I don't want to use an else branch here. Then what we do is, I think we need another variable here. Bridge current distribution. And we will set that to, we'll just set that to a script. Okay, so we want to set it to the distribution of whatever is currently in 310. And we want to use 310 here. Right. So I think we should start by just testing this, probably. Current piece \v something and distribution. So first we just want to test this. Oh, we need to create our random variable here. Use random value, we'll set it 0 to 100. So the piece that we're currently on is stored in variable 310, and the distribution is on 311. And we'll just test this a couple of times to make sure that everything is going as planned. Okay, so it's definitely not. That's good to know. That's why. Make this an auto run. Okay, so we'll just test that. We'll make sure that we're actual test now. We selected normal, didn't we? That should have been 20. This is very worrisome. Okay, but at least we've caught this here. Oh, you know what I think is happening? I don't think we're actually adding. Yup, that's it. Control variables. Current piece. Okay, add 1. That should help. It's always good to have a loop that actually iterates. We'll go with easy for now. Okay, yep. 0. Current piece is 1, that should still be 0, yep. Piece is 2, that should be 40, yep. 0, yep. 60, yep. Okay, so this is working correctly. And then, yeah, we start the loop anew. Okay, so far so good. Let's go to the actual correct page. That's always nice. Then, what we want to do is we want to add a conditional branch if... Oh, let's not use a switch. People are so gung-ho about switches, I don't get it. Some people, at least. Variables are like switches, except you can cram more information in. Like, in order to make a switch with a variable, you just set values to 0 and 1, and boom, voila, you have a switch. It's acting as a switch, but then you can also have multiple settings if you wanted to. It's great. I don't know why you would want to restrict yourself to just switches all the time. No. We're looking at random value. So if random value is strictly less than the current distribution. I think that's variable 1. And then, yeah, let's try that. And it'll be important to see how slow it is as well. The random value was 0. Okay, that's good to know. Less than 40. Oh, right, but we want to break the loop. Right. Strange that it's... Oh, right. Because we didn't actually set the random value to 1. It's set to 4? Yep, 4. That explains it. Okay. And then we also want to break the loop. Because we don't want to keep searching for more pieces. We just want to stop. Still concerning that we're getting the 0. Oh, the random value of 45. Good. It changed correctly. And that's less than 60, but greater than 40, so that's good. 81, less than 85 and greater than 60, so that's good. Yup. So this seems to be in order. Cool. And yeah, we're getting a lot more 40s than anything else, which makes sense, because that's the lion's share of all these pieces. So this is working great. So far, this is going a lot more smoothly than I expected it to. I'll be perfectly honest, especially because, as I said earlier, I thought about hard coding this. I very seriously considered hard coding all of this. This is much more elegant. I love it. It just works. Call me Todd Howard. It just works. Okay, the other thing we want to do is we want to run a little bit of script. I'm just gonna leave an empty script right there for now. Because, oh boy, it's gonna be fun. Where are we? Where are we? Script, here we go. Okay, so we want to set bridge pieces. And which bridge piece are we using? We're going to use bridge piece 310. And what we want to do is we just want to add 1. Except instead of dist, we want to go 1 to t plus equals 1. And that should work. And while we're here, we'll just add another debug variable here. Page 1 here. Control variables. Do I have anything in the 300s? No. So I guess we'll just use 50. What do I want to set it to again? Oh yes, I want to set it to... Yeah, let's just show a bit of text here. I'm just thinking, if we hit exactly 100, it might happen. So let's actually set this to 99. Because, yeah, that is a span of 100 things. And it shouldn't change the probabilities. At least not dramatically. Okay, so let's try that. Hopefully that'll work. I think it should work. But of course, I'm the one who thinks it should work, so let's go back on easy. Okay, 65, good. It has, okay, so piece 6. Which one is piece 6? Oh, here we go. Piece 6 is 3/4, has 1. Actually, maybe I should write this down. Piece 2 has 1. Piece 2 now has 2. Piece 2 now has 3. Piece 2 now has 4. 5. Piece 4 has 1. Piece 2 has 6. Piece 4 has 2. Piece 2 has 7. Piece 6 has 2. Piece 2 has 8. Piece 6 has 3. Piece 2 has 9. Piece 2 has 10. Piece 4 has 3. Piece 2 with 11. 2 with 12. 6 with 4. 4 with 4. And 7 with 1. So let's just check those probabilities real quick. Okay, so we have 12 plus 4 plus 4 plus 1 is a total of 21 pieces. So 12 over 21 is a 57% chance, which is significantly higher than it should be. And then 4 out of 21 is 19, which is right on the money, basically. And then the other, we also had 4 for the 6 piece. So then 1 out of 21 is 4%. And that's supposed to be 15%. So, not sure if there's something wrong. Let's try just giving it a couple more. Well, those certainly aren't going to help the case. That's piece 4 that has 5. Piece 6 also has 5. Piece 2 is 15. 6 has 6. And piece 6 has 7. That's piece 2, which has 17. Oh my word. And another. And another. And another. And another. And another. Okay, I think something might be skewed. 6 to piece 4, make that 7. 23. 24. 25. 26. My word. Ah, thank you. Good to see you, the Nerd Mansion. Not sure who you are, but it's good to see you. Thank you. Although, yeah, we have not done much work with the map right now. Let's see, this is piece number 6, which has a quantity of 8. We are getting 0 luck with the large pieces. Okay, I think we have enough data to show that either we've gotten extremely unlucky, or there's something strange going on with the random number generation. So let's try. Heck yeah. Game devs unite. Okay, so yeah, the stats were really off right there. But you know, we'll give it one more attempt here. Okay. So that's 1 for piece type 6. 1 for piece type 4. There we go, that's more like it. And that's for piece type 2. And another. And another. And another. And that's piece type 4, which now has 2. That one's a close one. 4 for piece type 6. Rather high, unexpectedly so. Oh, 5, yep. That's piece type 2, which now has 5. Okay, but at least we're seeing some of those larger numbers, which is good. Good. Piece type 2 has 6. Make it 7. Interesting, interesting. Wow. 8, 7. Just add another tally there. That one's at 9. That's at 10. That one's at 4. Now we're having difficulty with the medium pieces. Okay, so that's looks like 19. Oh wait, this is what a calculator is for. Okay, so we have 10 plus 4 plus 9 plus 5, total 28 total pieces, so 10 over 28 is 35%, which is closer to the 40% we're expecting. And then we have 4 over 28 is 14%, which is quite low. Then we have 9 over 28, which is 32, which is actually not too much higher than the 25% it's supposed to be. And then 5 over 28 is 17%, which is basically right on the money. So no, this is actually working correctly, which is good. It's good when things work correctly. I like that. I like it when that happens, because it it means that I'm not completely insane. So, maybe I can best describe this by going to the desk cam. Okay, here we go. Okay, so, where's the page? So we have our little bridge here. What did I do with that page? Okay, maybe I can't describe this best by going to the desk cam. Maybe I'm just a moron. That's okay. I think I have a backup here. Okay. So basically, we have this bridge here, and we have a span that is 1 unit wide, a span that is 3 units wide, and a span that is 2 units wide. This is obviously not to scale, because it's garbage. Then what we do, here, we can represent that with this. We have our 3 wide span, our 2 wide span, and our 1 wide span. These are all the bridges that need to get filled. Then what we do is we give the player a bunch of random pieces in order to fill that distance. And on the actual map, I'm going to represent it purely linearly, but these are a little bit more compact just to save space. And then the idea is that you give them these pieces and they have to figure out how they all fit together. That's nice and convenient and easy. But something like this might not work so well. And yeah, obviously that's not going to fit into that hole, so you're going to have to use it somewhere else. Like, perhaps... Oh, that's mightily convenient. Which piece is this? That's the 3/4, I think? Or 5/4. So the 5/4, yeah, the 5/4 is a very convenient one, apparently. Yeah, and then the idea is that they have to fit all of the, fill up all of the spans of the bridge, and then you can go across and continue on your journey. It's times like these that I'm glad that I spent all this time modeling this in Lego. May not have been the best use of my time, but it sure makes explaining things easier. And goodbye desk cam. Okay. So right now we're just designing the selection algorithm for all of the pieces, because we want to give our player a fair chance at solving it, but we also don't want to just give them the same pieces every single time. Because the idea is they're supposed to run this puzzle multiple times. Okay. Well, I do have one entire puzzle that's available for demo, that I completed way back last year, but I haven't done that much more since. I can show you the last puzzle if you like. I'll just, hey, stop that. Add in our player. So this puzzle is a fair bit different, which I think is good. Keeps things interesting. So you've got 8 characters. I know it only shows 4. And then you have to get every one of them into the cabin. So you chuck them on in. Like so. Now they each have a, Oh, really? Okay, Let me fix that for you. Here we go. Okay, let's just restart. Okay. We'll just select normal difficulty, nice and easy. So you take your characters, go down to the lower decks, plop them into each of these cabins. But the thing is, some characters happen to be a little heavier than others. And then we turn into this lovely little ghost, and we can go down to the hold and just spam it full of different products. Doodle-doo, doodle-doo. I'll just slap a couple more here. Oh, no, that's not what I wanted to do. Then we can go back up to the upper deck. We just talk to the captain. Checks the balance, and he says, "Oh, looks like we're nice and balanced, so we can set sail. Yay, we win the puzzle." And that's, yeah, not a ton of stuff going on, but I think it's fairly well put together. Good question. I haven't considered that. I probably should. Let's make a note to self. Ducal Ghost. Why aren't people afraid? Question mark. Just box that off, and we'll get to that another time. Okay. Back to the task at hand. Time to write. Super fun. Okay, hello. Okay. Time for super fun. How do you say? Oh, yes. Selection algorithms. Super fun selection algorithm time. We're probably like halfway through some of the stuff though, which is good. Then it'll be a matter of making sure things are properly balanced. Good old dihydrogen monoxide. And okay, so right now we've got our test thing right there. We've got it adding the quantity, that's good. But the other thing we need to do is subtract the cost. So let's actually grab this. And then what we do is we control variables. Not that one, it's not useful. Piece budget. Subtract, not the quantity, but the cost. And that should work, I think. So I'm satisfied that the distribution thing is working correctly. So that's /v. Budget is 301. Okay, so we'll just give that a test. We should start out with a budget of 72, which is just enough to fill the entire span. We'll stick to easy difficulty for now. Okay, so that's a piece number 7, which has a cost of 12. 72 minus 12 is 60. Beautiful. Then we have another, drops it down to 48. And then, so 48 minus piece number 2 has a cost of 3. So 48 minus 3 is 45. So that checks. Do it again is 42. Do it again is 43, is 39. Oh, and then a piece 6 has a cost of 9. Yep, that checks. Minus another piece type 2 is 27. Yep, that checks. And again, piece type 4 has a cost of 6. Yep, I think that checks. Cool. Oh. We do need to make sure that it doesn't take more than it's able to. Oh wait, common events. I don't need common events. Then what we do is we have another conditional branch in here. Or I think we just have another conditional branch outside. And we just need to make sure that the budget is okay. Oh, not switches. Darn, switches. Piece budget, yes. If it's equal to 0, then we also want to break the loop. So that breaks that loop. Okay. But then we need a check at the bottom to make sure that we haven't added a piece that's too large. So I think what we do is we add a check. Oh, actually, no, we don't want this check here. What we want is a check here after we've added the piece. So if the... Nope, we're still in switches. It's very annoying. So if the cost is less than or equal to... No. I think just less than, strictly less than 0. Okay. If it is strictly less than 0, then we actually want to Oh, is this gonna break the loop? I think it should break the loop before it runs this, but I'm not sure. Is there an easy way of testing that? Wait, what did I need to test? How have I forgotten already this quickly? Okay, so... Oh, right, we wanted to check if current piece got added before or after finishing. So I think we just need current piece. And we'll see if it matches the current piece between, or if it's one larger. If it's one larger, then we know we have a potential issue that we'll have to resolve. Current piece is 2. Good, okay. No, that's easy. It's easy to deal with. So we can delete that. And we just take that, we add. We add the cost back. If it's not less than 0, then we just want to add 1 to we just want to subtract. No. Okay, so if that's a valid piece, then we add 1. There we go. That's the way to think of it. Add 1. If it's not, don't add 1, just try again. Yes, I think that makes sense. And we will just add something to... Should probably add this in here as well. Oh, that's... Piece iterator is 303, and piece count is 306. Cool. So I think technically this first section of the selection algorithm should just be working. Technically. Hopefully. Just stick on easy because the numbers are easy. Okay, so we should get 15 pieces. One, okay. 2, makes sense. 3, 4, 5, 6, 7, 8. Oh. Oh, we may have struck upon an impossible budget. Yeah, it just keeps iterating through. No, we have stuck on an impossible budget. Wow, I didn't expect that to happen so quickly. Which means we need some kind of failsafe. Okay, I think the simplest failsafe would just be to include a count of budget failures, basically. we'll just add another variable here. Just add 1. And then if we have just a ton of budget fails, not switches again. If we have, say, let's go with 10 budget failures. Then what we want to do is we basically want to take this loop, except we don't actually care about the distribution. Oop. Push the wrong button. So maybe not quite this one. Let's actually go to, I think we have one here. Except instead of this, all this stuff at the end, we just want to set it to 0, and we want to set the quantity to 0. So we'll just reset it and then try again. Just add a comment. Check if selected piece is valid. Check if selected pieces find impossible. If impossible, it's not technically impossible to find a valid piece. I suppose taking too long to find a valid piece and reset. Although actually, do we actually care if we go over budget, but not Let's maybe actually just give it a little extra leeway. Let's not use 2 loops, that's for sure. Maybe we don't reset either. Just add a little error message to myself in case we ever run into that situation. That'll break the loop. And this should only, we should only see this. Piece allocation complete. Because yeah, the one thing we don't want to do is create an infinite loop that we get stuck in. So this should be enough to avoid that. Okay, let's see if we can get something out of it. We should get 12 pieces out of this. Oh. We forgot to make this. We didn't get the error, which is good. So it did actually manage to find a solution. Well, solution might not be the correct term for it. I'm too used to math problems where we talk about things like solutions. Oh, actually, you know what? This is wasting so much time. Let's actually take these. Don't care about their random value. There we go. That should be enough information. Okay, and now we see if it works. Oh, we're printing it. We're printing the information twice. Let's fix that. We should get 19 pieces out of this. So we hit 13 pieces out of 19. That's a lot lower than I was expecting. Especially because it was supposed to come up with an error. Did I have a check somewhere in here? Put that back to 0.
said you never do enough for me. I said, well, you never pull your weight. You said, how can you leave in such desperate times? I said, babe, it's not gonna change.
Okay, and then we just want to...
I've learned more than I wanted about how to win a fight.
That's set at 312.
I'd rather have learned to be more kind to those I loved the most. I'd rather have learned to
Budget is at 301.
to those I loved the most. I wish I'd learned to be more kind to you I love.
6. There we go. Okay, that should let us know when we have a fail. Because for some reason it seems to end randomly. So we should get 13 out of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we got 14 pieces when we were only supposed to get 13. Okay, that's good to know. Right. Let's change this to greater than or equal to, because we are starting at 0 and then working our way up. Okay, let's see if it works this time. So we should be getting 16 pieces. $12, and we're at a budget of 0. Insufficient budget, 1 failure. Still at 12 pieces. So yeah, there we hit 10 fails in a row because we went over budget. Nice. I do think that I should maybe change this to 15%. Let's even make it 20%. Just because we need to make sure that they actually have enough pieces to actually fit together. If we find it's too easy, we can change it. Insufficient budget. We've had 2 fails. Total budget of 3. Oh, I've just realized there's a problem with how we do this. I suppose it's not a huge problem, but let's grab that, because if it doesn't fail, then it shouldn't be penalized. So we'll actually reset it. Although maybe we don't want to, because it will end things faster. Actually, maybe not. You know what? Maybe it is actually good that it tries to end it faster if it's failed once. I think now it's time that we actually start looking at some of these distributions and seeing if they actually make any kind of sense whatsoever. And what we'll just do is, I think we're going to need another loop, basically. Press, I believe it's F12? What's the actual? Okay, and then we will print it. Set that to 0. Except instead of doing this, what we want to do is use console.log. Console.log. Name. And then we want to also have the T. I think those are the only piece of information we actually need. Maybe why we actually want to squish those onto the same line. Yeah, let's go with that. That should show us what we're actually getting. And then we can actually see if these puzzles are actually solvable. A novel idea. We're only going to get 9 pieces out of this. So the budget is too low, which is not a good sign. Okay, so we have 4 1/4s. And then 1/2. There's my halves. And then 2 3/4. And those are the 3/4. And then 2 1s. Where are my 1s? And do every piece except for 1s. No, I can't have, right? Right? Even I wouldn't be that thick. Right? Please tell me I'm right. Doesn't look like I made any 1s. Which means we're gonna have to improvise. How many 1s do I get? I get 2. Good thing I've still got the bin. So a 1 size is going to be 12 by 3. Let's pull up the desk cam. Okay. You happen to have a bunch of these lying around? Do I have like 1 by 4 anywhere? 1 by 3s. Oh, here's a bunch of 1 by 4. That's the sort of thing I'm looking for. Come on. Some of these bricks are very old, so might explain why they don't all fit perfectly. Yeah, I think this brick is definitely out of tolerance, which is a shame. Okay, and presto. So now we have our 2 1s. Okay, so we've been allocated all our pieces, and straight off I can see that this just isn't going to be possible. We just don't have nearly enough stuff. Yeah. We just didn't get through that budget nearly quickly enough. So we can get a fair way through it, but not quite all the way through. Let's actually try generating a different one. So far we've generated 17 pieces. Insufficient budget. 6 fails, 7, 8, 9, 10 fails. Okay. So this one has 13 quarters. Quarters are the 3s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm short one. Okay, it's very good that we still have the bin down here. Are you okay there, Spilove? Ah, there's a 1x3. Nope, that's a 1x4. Evidently doesn't check his pieces. There's a 1x3. Okay, there's our 13th. My goodness. And then we have 5 halves. 1, 2, 3, 4, 5. And then we have 5 3/4. 1, 2, 3, 4, 5, and 4 1s. There's 2, 3, 4. Okay, so this went over budget, and we had a ton of pieces, so this should be relatively easy to solve. Like, yeah. Yeah, not exactly difficult. So far, we've got one that was impossible, and one that was extremely easy and just had so many extra pieces. Actually, this is an unfeasibly large number of pieces, which leaves me suspicious. So we were supposed to have... Oh, shoot, I think we were supposed to have 19 pieces? I think this is more than 19 pieces. Yeah, I think we may have made a mistake. Just maybe, we might have made a bit of an error. Okay, so I think when we were allocating the pieces and yeah, see here, if we fail the budget, we keep the number of pieces, but we don't subtract the budget, which means that you can get up to 10 extra pieces just by randomly chancing your way into having into failing your budget. So what we actually want to do is we want to include this, and we'll do minus equals 1 so that it actually properly resets it, and now we can retest it. Although first, I do actually want to get rid of... I want to get rid of this, because it's running smoothly in terms of that now. So we're almost certainly going to need an excess budget algorithm that will deal with that somehow in a clever way. So basically we're writing at least 2 different algorithms. Oh wait, I have to stop my playtest. And we'll go ahead and use the right monitor so that you guys get to see what's going on. Stick to the easy. I'm sorry, what? Oh, right, we're at 11 pieces. 2 failures, 11 pieces. 3, 4, yep. No, I think it is a good idea that we don't reset the fails when we get close. Now we have 12 pieces. So we're supposed to have 20 pieces, I believe. Shoot, I should have been paying more attention. Okay, so... So we're supposed to have 6 quarters. 1, 2, 3, 4, 5, 6. And 2 halves. Halves are these ones. A 1, 2, 2 3/4, and 2 1s. And this should hypothetically be feasible. So let's grab that desk cam again. You know what, while I'm here, let's just check to make sure that my hotkeys are actually working. Desk camera. Ah, that's... oh. I see. Oh, yeah, so they have been arranged. Where's my... here's my documentation. Okay, so that's... Alt page up to hide. And control page up to show. Okay, that should make things easier. So now if I alt page up, hey, there we go. Hotkeys are working again. Okay. So this should hypothetically probably be solvable. Maybe. Oh. Now that is a tricksy one. So those 3/4 are actually a bit of a pain, it turns out. Okay. My fingers do not like. Wait, are these 3/4? How large is a 3/4 supposed to be? 9. That's only 1/8. No wonder. So we're supposed to have 2 3/4? Yes. So let's actually try that again. We'll just plop a 1 right in there. And in there. No wonder the 3/4 wasn't seeming to work. It was actually a 2/3. Perfection. So that's the exact solution. And of course you could obviously shuffle it around. So let's actually go ahead and try a different one. So we're supposed to get 17 pieces. Up to 17. So far we've got 13. Yeah, we're gonna get 13. So 7/4, which I believe is just one more. How many halves? 2 halves. Still got that. 3 3/4. And 1 1. So yeah, these are actually quite easy. Almost trivially so. And of course, you can arrange these in multiple fashions, which makes the ease even easier. So let's actually try like the hard difficulty. I mean, we haven't even tested to see that it works on the hard difficulty. Ah, so we have insufficient budget after only 5 pieces out of 18. 6 pieces out of 18 is when we run out this time. So we have 1 1/3, 1 1/2. So So 1/3, 1/2. Uh, 5 out of 1/5/4. No, sorry, 2 5/4. And 2 4/3. Oh, this is painful. That's not a 4/3. That is, though. And so is this. So, wait, are these the 5/4? It should be. Yeah, so this is impossible. So straight off, we go from trivially easy to impossible. The joys of very hard. Let's actually try just hard. And once again, we've failed super early on. So 6 pieces, and we've already had a failure. Several failures, and now that we're on 7, we've had even more. Yep, so 7 pieces is end of the line, out of a possible 17. So 1/4. 3/2. 1/3, and then 2 7/4. Okay. So yeah, let's take a look-see, I guess. So this is actually a potential issue that I hadn't considered with my Lego style modeling. Sometimes you may have halves that don't fit together nicely with the other pieces you're given. But this is possible. We do now know that this is possible, so it's at least possible on hard. I almost need bins for these. Okay. Let me just... I think I just want one more quick change here. Just add one quick more line of script. Console.log. Just add in a separator line so I can actually see. So let's try this on, let's say, so 10 pieces in this time. Interesting. And then we get to 12. Oh, I put that in the wrong place. So we get 2/6. 1, 2, 2/3. Should probably be sorting these a little bit more as I go. I've sworn I had a spare quarter kicking around. Oh yeah, I do. There's one. And we need... oh, not a quarter, a third. We need one more third. And then we need 4 halves. 1, 2, 3, 4. And then 3 2/3. And then 1 1. What difficulty was this? I think this was normal, which still has the ones. Yeah, I think so. Okay, so let's try this. Oh yeah. Nice and easy. Actually, once again, almost trivial. Yes, that is correct. Right now we're just testing to make sure that our algorithm actually works at all. Okay, let me fix this, because that was annoying. Okay, there we go. Okay, now we can do that. It should give the output. Let's do another normal. So we could get up to 24 pieces, and we're getting half that. I should also add a check. If the budget is equal to 0, just stop there. Okay, so we have 3/6. There's 3 right there. 1/3. 5 halves. 1, 2, 3, 4, 5. Yeah, I definitely could do something like that, but I just can't be bothered. And then, oh, right. And then we have 1 2/3. And then we have 2 1s. Good. And yep, that matches the distribution that we're sort of expecting. Okay, and is this possible? First test. So we can put a 2/3 and a 1/3. Slap down a couple of the ones. Here's where things get interesting. Oh wait, these are sixths. So yes, actually this does work. It is possible. Huzzah! Okay. So, feasible solution. That's good. It's always a good sign. Wonder if this is... I mean, it did feel quite easy, but perhaps not exactly trivial. Let's try a very hard. So we're only going to get 6 pieces. We'll get 7, maybe 8. So we're actually going to get some 12ths in. Okay, so 2 12ths. There's 1. Make it 2. That's the first time we've actually seen any in these tests. 1/4. Do we need any thirds? No, we do not. So there's a 1/4. And we need a 1/2. Always got lots of those kicking around. And then we've got a 3/4. That's a 5. There's 3/4. Here's a 3/4. And then we have a 5/4. Perfect. And then a 7/4. I think that's one of the few ways you can actually use that. Oh, did I miscount something? Oh yes, we get 2 5/4. Which is still impossible. Almost. But we're still missing 1. I think maybe what we need to do is... Budget pieces max, yeah. In variables value for that's 301. And make that And that's 303. And that's 306. Hey, how's it going? Okay, chuck that in there, and then we can run our test. That should have a little bit more information. Hey, that's pretty good. That's pretty good. Pretty good. Things are going relatively smoothly. My algorithms haven't completely died yet. Let's go for very hard straight away here. Insufficient budget. We're only getting 4 pieces. Oh, but yeah, no, that actually makes sense. 5. Oh dear, we're only getting probably 6 or 7 pieces. This might be a bit of a tricky one. Ah, yes, so we have 2 leftover budget, not great. And 5 pieces. So we have a 2/3. 2/3. I think I have a spare 2/3 somewhere here. Oh, it doesn't look like it. There we go. A 2/3. A 1/3. Where's my 1/3s? There they are. 1/3. A 3/2. Oh joy, which ones are the 3/2? Pink? Nope. Here we go. Here's a 3/2. How many of those do I have? 1. Then 2 5/3. 5/3. No. 5/3. No, these are ABS Lego. And they're bricks, not Legos. I don't know anyone who calls them that. But yes, that's the general idea. 5/3. 5/3. That's 4/3. Do I even have a 5/3 piece? Is this a 5/3 piece? It is. So 2 of those. And that's it. Oh boy. Can we make something of ourselves with this? Well, that's a nope. Did we get a half? We did not. So we got a 1/3, a 2/3, 2 5/3. Ah, yes. So we're within budget, but yeah, that's not gonna fit. Yeah, I mean, I have no idea exactly why that is. As I said before, I'm not a materials engineer. But I suspect it has to do with the fact that ABS is probably ABS is amorphous. I don't think PVC is as well. And I think that makes it easier in terms of extrusion and the actual extrusion process. Because the pressures and temperatures are very intense for extrusion molding. And yeah, I don't know if PVC works well in those conditions. It could be that PVC instead of extrusion molding is like you just, I mean, as you said, it's still very expensive for 3D printing as well. So yeah, it could be that PVC is more liable to like catch on fire or something at the pressures and temperatures that you would use for extrusion molding without being first adulterated with certain additives that would be quite expensive. I honestly don't know the reason. Let's try another very hard. So we're getting up to 16 pieces, and we're gonna get much less than that. So we're getting 5 pieces this time. Oh boy. So we get 1/4. We get 1/3. Where's my 3/4? Here we are. 1/4, 1/5, and 1/3. Oh, come on. Thankfully, I know the ancient techniques of debriquing. That is to say, leverage. And we have spare budget of 6. So yeah, we are gonna have gaps. So if we had those 6, if we'd gotten them in 12s or 6s or even a 1/4 and then some other things, or a 1/3. Lots of options with that, but we got unlucky. Okay, so now I think we've successfully proven that this selection algorithm alone is not gonna cut it. We're definitely gonna need some modifications. I'm just gonna group these up, so that way it's easier to find them again. Chuck a couple of the 3/4 together. Okay, so the first thing that we need to add is our extra pieces, because thankfully I had the foresight to include extra pieces. And those are not going to be dependent on the budget. See, I was thinking ahead when I wrote the pseudocode for this. Not very far ahead, but I was thinking ahead. This is the important loop right here. Oh, and we actually don't need that. So let's actually put this in our else, because I think it makes more sense there. And then we actually don't need this. And then what we can do is we can take this whole loop and put it into a how do you say? A common event. So we'll just copy that, press OK. Common events. Okay, so how much space did I leave between these two? So I left that one to 25. We might need a few more, so we'll, you know what, 25 should be enough common events for that. And if it's not, then this is bridge. And this is gonna be allocate piece by dist. And we'll change this error code. CE 0250. And we'll say that it's... We should probably actually just run a... I think I have another common event just to not set difficulty. Event ID of current event. And I'm not sure what variable that writes to. Let me just check my database. Variable 12. Let's actually temporarily set that to 0. And we'll have this run the loop. Yeah, instead of this loop, we're just gonna delete that, add our common event. That's 250, so we've got a fair amount of scrolling to do. Okay, and then we can test. Actually, cancel. Let me just... Just turn that off for now. Save. Easy. That wasn't supposed to happen. It was supposed to print an error. But somehow we... Okay, I'm not sure what happened. Oh. There's only two things. One say one word, 3U? What? I'm very confused. Okay, so I actually want to do that as well. Let's try doing that. It shouldn't make a difference. The allocation should not be complete. Why is it not spitting out the error? What if we just copy that? Oh, actually, we need a little bit more than that. We need this and that. Just try that right there. Before anything else happens. Okay, so it's not the error message. That's good to know. The error message does work. Okay, so that's not the problem. That's not the problem. Let's just show a balloon icon. Sure, exclamation. Just to make sure that something is happening, that it's ever running that code. That's very concerning. Nothing happened. It didn't even pop up with the other thing. So why didn't anything pop up? This is still on auto run. We have it doing that. Okay, let's... Oh, we need to fix this. Still don't understand why it's not coming up with the error message. Let's try it when it hits 2. It's very concerning. Oh, because we're breaking the loop first. Let's try it now. There we go. And now it's stuck there, which is what we're expecting because we told it to do that. But now let's fix that to 13. There we go. Now, this should work the same as it was working before. New game. Normal. Budget -2. Interesting. So now it's going over budget, which it wasn't doing before. Oh, because it can over allocate now. Because I took the budget out of here and I put it into the else statement. Really need to fix my sound jack at some point. Okay, let's actually fix that. Because otherwise we might have some really funky stuff. Yeah, so this should actually go... So that will allocate the piece. Then we check if it's an invalid piece. And we add back the budget. There we go. Now we won't go over budget. Let's try it on normal. Insufficient budgets. Yep. Cool. So we got 16 pieces out of a possible 24. All right. 6 sixths, 2, 4, 5, 6. 5 thirds. 1, 2, 3, 4, 5. 5 2/3. And that's the lot. So this is actually a very easy one, I think. Just because it gave us so many of these small ones, right? Like you slap a 2/3 there. 1/3 there. Cram that full of 2/3. Then we can just fill up the rest of this with our sixths. So this actually didn't give us any of the challenging pieces, which is kind of a shame. Maybe we should do something to ensure that it gives us at least 1 or 2 challenging pieces, although those also take up more space, so that in some sense does make them easier. Yeah, no, for... Oh wait, that was normal mode. No wonder it was so easy. Let's try it on very hard. insufficient budget, 8 pieces out of a possible 20. And that's all we're going to get. So yeah, I'm definitely noticing that on the hard difficulties, we run out of budget long before we run out of pieces. Okay, so a single 12th. It's very nice. Always good to have 1 or 2 12ths. And then a 6th. A quarter. 2/3. Separately, of course. And then 1 4/3. And 2 7/4. Oh. I'm not sure if this one is actually possible. No, I don't think it is. Because we're at budget, but look at that. You're never going to fit that. And you can't fit it there either. But you don't have a choice. So it's the perfect solution in terms of budget, but it just doesn't fit. But we can fix that with the extra pieces. Okay, so we'll just clean up some of this a little bit. And there we go. So now we need to add in our extra pieces, which I was talking about before. We'll just add a comment here, because this is allocation complete. Okay, and now what we want to do is we want to include a loop, and we'll actually add a comment. Extra pieces. Allocation. Okay, and what we just do is we take the start of this loop, except instead of piece iterator and piece count, we don't want to use piece count, we want to use extra piece count. Same idea though. And these ones don't get verified as like they don't check against the budget, the extra ones. We should actually almost move that in with our common event. There we go. And we'll need to set the piece iterator to 0. add to it there. Set to 0. Save our changes. And actually, I think I want to do our extra afterwards. And whoa. Okay, see ya. We'll call this plus extra. Application complete plus extra. Console.log including extras. Extras, there we go. Okay. And now, if we run that, this should now include our extra pieces, and we'll see how frequently we run into impossible things again. Because then we're going to need a third algorithm, or possibly more. So let's just jump straight to stress testing. Insufficient budget, that's fine. 6, 7, 8, 9, 10. Allocation complete. I should have done my allocation first, because now I don't see it with the extras. Let's actually, then we'll just add a bracket here. That should be 304. So that'll add those two values together. Okay. Let's see how that works. We'll jump once again to very hard. Insufficient budget, yes. Stuck on 16, which was interesting. $37 out of 23. Interesting. So we only had 8. But somehow we got... I'm confused. Oh, because we took the 23 and then we added... I see. Yeah, so this is not supposed to be... That's not what it's supposed to be. Okay, that's fine. Okay, so we have 1/12, 1/6, 1/4, 1/3, 1/2, 2 2/3, 2 2/3, 3 5/4, 1 4/3, and 2 7/4. So this may actually be, once again, super easy. But then again, this might be one of those ones where it's not super obvious how it's supposed to be solved, so... So obviously, we do one of those. So that's quite easy. I think this may just be a problem of the distribution being a little imbalanced. Because, yeah, that was trivial. We did that in the minimum number of pieces. Okay, let's try a different one. And we'll try on very hard again. So 1/12, 0/6, 1/4, 2/3, no halves. Not that we used that last time. Uh, 2 3/4. Do I have any 3/4? My 3/4. It's not a 3/4. Here we go. How many of them? 2. Um, 3 5/4 again. Uh, 1 5/3. Okay. So this one might actually be more of a challenge. Obviously, we still have this. You turn it the correct direction. So that's still our 2-slot, really easy.
You say I can be loyal, not faithful. I say fine, but
So that's not gonna work.
favor. Our love is just too big seeking. It's the dream girls that you like best, the ones that never let you rest. You run and run, but you don't find
Oh.
they live only inside.
Yeah, so that was more difficult. Still very easy. Once again, we solved it with almost the minimum number of pieces. So, and now those are behind the desk. I'll get them later. Let's see how it is on normal. So this extra pieces deal might actually be a bad idea. So we're supposed to get 13 pieces. We're getting at least 12. Okay, what do we got? Okay, 2/6. 6/3. Oh boy. 1, 2, 3, 4, 5, 6. 2/2. 4 2/3. So that was our halves. 2/2, 4 2/3. Oh, we're on normal, right? So that's a 1. That explains why these are all lower. Once again, you can just shove a bunch of 2/3 there. Come on. So yeah, once again, that was quite easy because, yeah, that's a free one, that's a free one, that's a free one, that's a free 2, and that's a free 1. Although maybe I'm just thinking that these are easier than they actually are. Maybe this puzzle is just too easy to start with. Either that or it's impossible and there's not really an in-between. Like, either you just RNG and either you get something that's super easy or you get something that's impossible, and there's not really any sort of intermediate things to provide you with the challenge. I don't actually know, but that is sort of what it seems to be leaning towards. Either it seems to be a very simple solution or a very difficult one. Although we did see some more tricky ones with, how do you say? The very hard. At least without the extra pieces. So we ran out of budget at 7 pieces. Got an extra 3, 4? I think it must be 3. Oh wait, no, it would be 6, because it's 0.2. So 0.2 might be too high. Although, we could actually vary that with the difficulty. That might actually help a lot. So we have 4 quarters. Three halves. Three 3/4. And 3 7/4. Oh wait, no. Those are the 7 quarters. And these are the 3/4. So this one might be slightly trickier. Slightly. So yeah. That's very easy. I think, yeah, we could have just used a half there, assuming linearity, so 2, 4, 6, yeah. Once again, very simple solution, and there's multiple of them. Oh dear. Oh dear. Oh man. I am massacring these 7/4. And I don't mean that in a good way. Is there a convenient way I can actually put them together? Yeah. Yes. I think that's the only real way. Like that. Okay. There we go. Okay, so that one was slightly more challenging, but I think we might need to switch it up even more. We might just need to, you know what, let's try it on easy. We run out of budget straight away. Still have 6 sitting there. Oh, there we go. So this gives us 3/4. 7 halves. 1, 2, 3, 4, 5, 6, 7. 5 3/4. Dear lordy. 1, 2. Here's 2. 4, 5. 1, 2, 3, 4, 5. 0 ones though, so at least that much is going to be trickier. But that's going to be the only tricky part of this. Yeah. Oh. Now that's... Oh yeah, no, that does work. So the easy was actually more challenging than the very hard. In a certain sense. It was still very easy, just stack basically whatever pieces you want together. Okay, but we're gonna give them each piece one at a time. So what if we try simulating it like that? I have a feeling that might increase the difficulty. In fact, I have a pretty good feeling that that will almost certainly increase the difficulty to sort of what I was kind of hoping for. Not really sure how to simulate it. Because I already know the answer. Okay, I have an idea. It might not work, but I also need to use the washroom, so just give me like 5 minutes, and you can enjoy listening to Maya Solove, and can't remember his name, but he's also got music here. Kevin MacLeod, yes, Kevin MacLeod, and Maya Solove, and I'll see you in 5-ish. Bye. Okay, so my initial plan didn't work out. I was thinking maybe my siblings are still up, and I'll just ask them if one of them can, you know, feed them to me one at a time. Something like that. But then I was like, well, I have 3 yogurt containers. By the way, not sponsored by Astro Balkan Yogurt or whatever, because guess what? We have Kirkland lids, not sponsored by them either. Those are just the yogurts that we happen to have. Or rather, the yogurt containers that we happen to have. And the lids, which are from different companies. But hey, thankfully yogurts are standardized. So what we're just gonna do is we'll just do this, go back, and then what we'll do is we'll generate 3 entirely different things, and we'll shuffle them up, roll a dice as to which one we're gonna pick, and then yeah, go from there. So let's do all of these on the very hard difficulty. Okay, so this one gets 1/12, 1/6. I have noticed a flaw in this plan in that the smallest ones are going to come last, but 1/2. This is still a better simulation, I think, than nothing. 2 5/4. Yes, 5/4. 1 3/2. 1 5/3. And 3 7/4. So that's one bin done. Now we'll just grab a second one. Also on the very hard difficulty. And we need 3 1/12. And yes, I've grabbed 3 of the same brand of each type, just so that way I'm not going to be biased in any way accidentally, so that there are no distinguishing marks, really. 3/3. I feel like I'm making a very strange soup. 1/2. 2 2/3. I think I made so many of these. 1 3/4. 1 3/2. Yeah. Is that one? 1 5/3. These bad boys. And 1 7/4. Now, unfortunately, the lids I couldn't quite find any perfect one. So that's gonna have to do. Okay, and then we simulate another one. Also one very hard. Okay, so 2/12. 2 into the soup. 2/6. I have 2 right. 1/4. 2/2. Oh. There we go. 2/2. Into the soup with those. 1 2/3. 2 5/4. Oh dear. Donk. Donk. 2 4/3. Oh boy. 2 3/2. There's 1. Is that another right there? Nope, that's a 5/4. Who would want a 5/4? And then a 5/3. Into the soup. And a 7/4. I'm running out of desk space. There we go. So we'll say that the one on top is 5 and 6, 3 and 4, 1 and 2. So which is it gonna be? It's gonna land funnily. A 5. This one. Okay. And we're only going to pull one out at a time. Oh. Has rather predictably the same effect. Oh. I think. Okay, I'll hold out for one of the 12th. In that one. Okay. And feel the 12th there. Okay, we'll do this one first. Oh. Okay, so I can't use this piece. Can't use this piece. Can't use this piece. Oh! This is actually impossible. Or is it? No, I think it is. So, yeah, I guess that's a thing. We may need a more intelligent algorithm. Maybe it's not impossible. Well, I suppose those can stay there. We can use that for the 2, but I don't think that... Oh, no, we can't use that for the 2. We could use that there, but then we have nothing to fill that last slot. And we could then put that there. But I think that's as good as we get. And then, yeah, we still have a missing third. So it is still possible to generate impossible outcomes. Okay, let's try generating a different one to replace that, because... Try another very hard. Okay, this time we have 1 1/12. Let me grab the lid. Okay, 1 1/12. 1 1/6. Same as before. 2 quarters. 1 1/3. 2 2/3. 1 3/4. Here's 1. 2 4/3. 1 5/3. And 2 7/4. We'll just reshuffle these. Okay. 1. Oh, no. That was not what I was supposed to do. Okay. What's our first piece gonna be? Grab a nice small one. Sure, that'll do. Let's just plop that there conservatively. Let's take that one there, perhaps. There's a 3/4. Would have been nice to have that 3/4 a little later, I guess. Here's a 1/12. I'm actually not going to use it. I'm going to avoid using it. Yeah, I don't have a place I can fit it without taking out one of those. Oh, there's another. So I've taken out a single piece. Stick that in there. So it's definitely, I don't think it's impossible, this one. I think that if you had foreknowledge about what you were doing. Quite. Yeah, there we go. So it's relatively easy, but if you stick to an extra rule set of not just replacing and seeing them easily, then it is substantially more difficult. Which is a good sign. Maybe this is actually worth pursuing. We'll try one more, but then I think we should probably take a better look at our algorithm. No, I should reshuffle. Three is the middle one. Okay, what do we got first? Ah, nice big 3 halves. I'm gonna try the 2/3 up in there. Ooh. You know what? Let's try for it. Oop. Gonna plug that there. Oh, there's another half. That's very nice. Ooh, there's the 12th. Sort of had a tie there. Well, that's not gonna fit. That's not gonna fit anywhere either. Okay, if I replace one tile, stop that. Then we're sort of hoping for a quarter. But there might be a quarter, or a quarter substitute. We are sort of waiting on, or not a quarter, a third. No. Okay, let's do a reset on that. Just had one of the 12ths fall over. Just annoying. Ooh. That's quite good. That's too large. Those are both too large as well. Oh. And yes, that definitely does make it more difficult. But is it possible is the real question now. Let's just make sure of that. So perhaps if we do something like that. Oh yes, so you can quite easily solve it in 6 pieces. I think probably multiple different ways like this. Yep. Also use that like so. Yep. Or you could then put these there. Yeah, you could almost solve this 3 times over. But when you're restricted to those rules, then it's much more difficult, which is good. So I think that maybe so long as we reduce the impossibility factor and maybe just try to make parts of the algorithm a little bit smarter, this might actually work. We might not have to make too many changes. Maybe some balance changes with how certain things are laid out, but I think all in all, this is a really excellent start. And yeah, hopefully sometime next week, we'll be back. I say next week, it's this week already. Yeah. Time sure flies, eh? But yeah, hopefully sometime relatively shortly, we will be trying to slog our way through the how do you say? The actual user interface things. And we'll, yeah, because once that's done, I think most of the math is complete, basically. Although we'll need some kind of detection for actually winning the puzzle, but I think that should be relatively simple. At least when we get down to brass tacks with it. Compared to the selection algorithm and actually finding a way to give the player the pieces accurately and then, you know, give them a fair piece, you know, give them actually set up the puzzle properly and make them able to manipulate it. Once we get that done, then I think this will be a lot easier. But yeah, until next time, I suppose. Thank you all for joining me. And whether it's 10 seconds, 10 minutes, we'll be back next week. I have a tentative schedule in my head for how this season is going to go. But I haven't released it yet because my work schedule is still developing and various other things. Yeah, I wouldn't be surprised if I was back tomorrow. I might not be back until Wednesday. But until then, thank you very much for joining me, and I will see you next time.